Okay, now how are we going to model x? So we are talking about this function and we are trying to model x, and we know that x is at least um, we need to start with current movie going rate minus the break-even rate. And if that's what x is going to be without any modification, this is what the probability function is going to look like. So it starts with a fairly high probability of subscription, which is very optimistic, and then it increases gradually to zero point 0.1. On this side of the ledger, it is somewhat pessimistic because you would expect the probability to increase sharply here, but it is increasing gradually. So we know that this is not a good model, but it is a good starting off model, but it is not. We have to do some more work with this. Okay, so what we can do is we can take this start, starting point, and say, okay, we're going to multiply this with a factor, and let's call that sensitivity factor. The sensitivity factor has multiplying effect on x with respect to the difference between the current movie going rate and the um, break-even point. So if the sensitivity factor is less than 1, then the difference between movie going rate and break-even point is now reduced. Okay, so if you say zero point 0.5, then this difference is halved. If it is 1, it's kept as is, and if it is greater than 1, then this difference is amplified. Okay, like if it is 2, then you take the difference and make it double. Okay, so let's see how sensitivity number affects the curve. Suppose if we use a sensitivity of 2, then this is the uh, shape that we get with respect to the current movie going rate. As you can see that negative sensitivity, I'm sorry, less than one, sensitivity rate factor less than 1 is not reasonable because it's actually making it worse. So sensitivity has to be greater than 1. Reasonably, reasonable logic says it has to be greater than 1. So if it is 2, then it's going to be like that. So you do get some accelerated increase in probability around the break-even rate. And if it is 3, it's even more steep. So what should we use? Should we use 2 or 3, or should we even consider break-even sensitivity factor less than 1? Okay. Which is not reasonable, but still we may want to, just for the sake of analysis, we may want to look at it. So sensitivity factor then becomes a kind of an unknown or uncertain variable that we want to simulate and then see how it affects our outcome from the model. So this seems to be a good way of modeling x. So our probability then, so here is sensitivity equal to 5, then the increase in probability is even steeper. Here and reflects a much closer to optimistic estimate. So larger sensitivity, you can generally say that it is optimistic. Smaller is going to be pessimistic, at least in the segments that are more likely to subscribe. So larger sensitivity is more optimistic. All right. So this is going to be our S function. This is also called S function because it looks like S. So this is going to be our probability subscription function. This is how we will model probability. So it is 1 over 1 plus e to the power of minus x, where x is going to be a sensitivity factor multiplied by the current attendance the current average attendance for the segment, okay, minus break-even attendance. So this is how we will model probability.